Hi everyone, this is a very short video on density, and when you finish this you should be able to calculate density to identify unknown substances. So first let's make sure we know what density is. So this is defined as mass per unit of volume, and like I said, it can be used to identify the material an object is made up of. So this is like an intensive property, which means it does depend on what the composition is. Doesn't really matter how much you got, because they would be in a specific ratio, volume and mass, but it does depend on what you're made up of. Your units for density are grams per liter, or grams per centimeter cubed, or grams per milliliter. So normally I will say we use those two more often. And your formula is mass divided by volume, which is why we've got grams on top and some sort of volume measurement on the bottom. And this is how you would see it, like on a sheet. Be aware though, you could be asked, and you will be asked on your mastery check, to solve for any variable in this formula. So you could solve for density or mass or volume. So you may have to rewrite this formula to solve for one of the other ones. So for instance, if you want to write, or if you want to solve for mass, so let's say we've got density is equal to mass over volume, and you want mass, we're going to box it off, okay? We need to get mass by itself. So we are going to multiply both sides by the volume. That is going to cancel these volumes out. Ooh, let me mark them out actually. So now you've got density times volume is equal to mass. So you can solve for these in any variable that you might need. The last thing I want to add here, I thought it was on here, so I'm just going to say it. So for water, for H2, oh, that was sloppy, sorry. 1 milliliter is equal to 1 centimeter cubed. You cannot make this assumption for just any liquid, but you can for water. So if I were to say, if I were to give you the density of water and it was in grams per milliliter, but I want the volume in centimeters cubed, you do the math the exact same, you get the same answer. I just want you to know that comparison there. So this is a good little gift to show you how to set up these samples. So if the mass is 200 grams, volume is 400, you divide those and you would get your density from there. Okay. Oops. All right, so let's look at this example. And it says a certain liquid sample has a volume of 14.7 milliliters and a mass of 22.8 grams. Calculate the density. So we are going to look at our givens. Okay, so our given here, we've got a volume of 14.7 milliliters, and we've got a mass 22.8 grams. And I'm going to show you for when we do things on paper how we annotate a math problem. So you are going to underline what you're given, okay, and you're going to circle what you're looking for. And the reason we do that is it'll save us time on writing all these out individually. So underline what you're given, circle what you're looking for. So we're looking for density. Then if you need that extra help of writing it out, you absolutely can. But a lot of times we just save time by underlining and circling up here. So we know our formula is D is equal to M over V. Okay. So we're going to plug in our values. So we're going to do, oops. Scroll that out. We are going to do 22.8, which is our mass. Ooh, rough. 22.8. We are going to divide that by 14.7. Okay, there we go. And when you plug that in, you will get an answer of 1.55. And don't forget your unit, which would be grams per milliliter. Okay, so be sure to keep your units, let me shrink this down, with your values so that you can plug them in correctly. So you see we underlined our units here, I wrote them there, and see I almost plugged them in backwards here because I wrote them the way they were given in the problem. So just make sure you're aware of that. And then you have an example down here, which is also in your notes. So I want you to pause the video and I want you to try this, and then you can go over it with a group in a minute. Oh, so now you should be able to easily calculate density to identify substances. Now, to identify the substances, I'll add this right here at the end. It would be that I gave you a list of substances and a list of densities. You would calculate out the density and then find the one that's closest to it. That's how you identify. But you should